Hello everyone. Today in this video we are going to demonstrate a very beautiful simulation. We are going to set up step by step a drop test analysis in Abaqus software, in Abaqus user interface. And let's start step by step. Let's import our geometry. We are going to simulate a teapot, the drop test of a teapot. It is the same model that we have analyzed in a previous video, and we have performed a heat transfer analysis on the same model. And now we are going to, let's say, smash this teapot, because we're going to set up a drop test analysis, and we are going to include the fracture in our material. So we had import the CAD geometry, and let's create an analytical rigid surface for the ground. Let's use the sketcher of the Abaqus and create done. Perfect. Let's first create a point in the middle of the surface using this option by clicking on this point and this point, the points, and here we have created this yellow point in the middle of the surface. Let's create a reference point here. This will help us for the boundary conditions later in the video. And let's create the instance by including all these three parts. So before continuing with the assembling of our instance, let's create our material. So as we said, this teapot is made of a ceramic material, a brittle material, which for sure we have to include the density of this material, because we are going to run a dynamic analysis. So let's check my notes. Density. Okay. Elasticity. 65 gigapascals and Poisson ratio 0.2. Perfect. And we are going to include this option, concrete damage plasticity. Perfect. So for these values, please also have in mind that these data are theoretical data and are not experimental data. So if you want to characterize your material, you have to collect experimental data and validate your model. So compression behavior. Perfect. Perfect. You have to include the damage parameter versus inelastic strain. Okay, something is not well written here. Point. Nice. And sub-option for retention damage. Perfect. So now we have to create the relevant section for this material. Ceramic material. Perfect. Okay. And we have to assign on the teapot and the cup. Perfect. Ceramic. Nice. Not create, assign only. Okay. Perfect. So let's go to the mesh module, and the geometry is quite complex, so we're going to use tetrahedral elements. Nice. And here we're going to create explicit family of elements. Modified element deletion, yes. And specify the maximum degradation 0.9. Okay. And let's use an average, let's use one average global size. Let's mesh the part. Perfect. So let's do the same for the teapot base. Element deletion, yes. Explicit, element deletion, yes. That's degradation 0.9. Not modified. Perfect. Perfect. So we have meshed our parts, and let's move forward to create the assembly. So what we usually do in drop test analysis is that we assemble our parts close to the impact surface, and we assign as a boundary condition an impact velocity that is calculated according to what is the height of drop that you want to consider in your analysis. So what we are going to do is, let's say, move the teapot and the cup, and we can click on this point, and now we can click on this point. First of all, click OK. We have moved in the center of the analytical rigid surface, and now we can click this tool, this translate instance again, and now select again the geometry, and here this is the start point. Click enter, and now we have to put it a little upward on the y-axis, let's say 20 millimeters upwards. Perfect. So now if we want to make an inclination of the teapot, we have to use this tool, rotate instance, again select the geometry of the both parts, click yes, And here in Abaqus says select an axis or a start point for the rotation vector. So we can select this point, first point. Let's rotate. We can select the second. And here now we can give a small angle, 30 degrees, let's say. Okay, we don't want this inclination. Let's click back and select -30. Perfect. So let's click OK. So as we said before, this strategy, this way, is the most computational efficient way to set up a drop test simulation, because you could have an alternative that you can move your part at the height that you want to leave it and drop, but this means that Abaqus have to run and calculate every time step during the fall, and it's not a computational efficient way to do that. So here, let's now create a time step, an explicit dynamic time step, step 1 on time period. I believe that a few milliseconds are enough. So let's make 10 milliseconds for the analysis. If you want, you can use a mass scaling option, but you have to check it afterwards. If you see that the time step is too small, you can speed up a little your analysis, but carefully. You have to do it carefully, that. And the field output requested and the history output requested can be created for this step. I usually change these space-time intervals, and I ask for values 10 milliseconds, let's say 0.5 milliseconds, every 0.5 milliseconds. Mission points, perfect for the whole model. I'm doing the same for this. Nice. And if you want to use a mass scaling option, you have to include this value to check the percentage of the mass scaling. Now we didn't assign a mass scaling option. You have to move forward and create this. First of all, you have to create a surface for the analytical rigid. So go here to the assembly module and create a surface here. Select here, click done, and select the brown. It's the surface that it's shown now. Perfect. So here, interaction properties, contact, interaction properties, mechanical, tangential option, not frictionless. Let's assign a value of 0.3 and hard contact for the mechanical. And now here, and general contact, it's okay for this analysis. Just here you have to include the interaction property that we created before. Nice, perfect. So we can go on and create here the boundary condition for the fixed support of the analytical rigid surface. This is why we had created this reference point here in the middle. Just click it and select and constrain all the degrees of freedom constraint for the interaction, for the boundary condition. So now, as we have said before, since we have translated our part, our geometry, very close to the impact surface, the only we have to do now is to assign an initial velocity. And you have to calculate the initial velocity in accordance with the height that you want to simulate your part. Let's say if you want to 1.5 meter, to let it drop from 1.5, you have to make the calculation and the conversion from the free form from the free-fall formula and go here to the predefined fields. Let's say create step initial and mechanical and velocity. Select your part, click done, and V2 is in the y-axis. We have to put a value, let's say 4000, that is something like less than 1.5 meters. It's minus and it's in millimeters. So here you can see the arrows. So now we are ready to run our analysis. Let's go here, click create job, your model, teapot, drop 4000. Select your processors, click OK, right click and submit. So I have already run some analysis and I will show you the results from similar analysis here. When your analysis is completed, you can right click and check the results. And here's the analysis. And here is the result of the analysis with the element deletion. So you can go here, click features. You can see it this way, and you can click here and let it run. You see the crack initiation and propagation. Okay, something that I forgot to mention here is that for the element deletion, you have to go back to yes, you have to go back for the element deletion and click model, edit keywords, and here in the model you have to add some lines in the keyword. I have make some notes here. Have to go under the material definition, concrete damage material here before the interaction properties, and include this one, concrete value failure. This is the last values for the tension. This one is for compression, and this is damage factors, 0.9 and 0.95. Click OK, and your model will run properly. So guys, I hope you like my video. Stay tuned for next videos, and thank you for watching. Bye bye.